Hi students, let's look at this question here, which is on application of integration. This was taken from the year 2013 AJC Promo, question 8 part B. Okay, so the diagram shaded region R bounded by the curve y minus 2 square plus x plus 1 and the line y plus 2x equals to 6. And you're given that R is a region bounded by these two curves here. So when the volume generated through 2 pi about x-axis, leaving your answer in 3SF. Now, when you say 3SF, you don't really need to use integral. You don't need to find exact integral. So just use GC. Okay, just remember that. Use GC. Do not go and find the exact integral there. Now, straight away, you know that this curve here, so R here, if you look from x, there are actually two equations for the curve here, right? For apart from the straight line, the straight line only has got one equation, but whereas for this equation here, you have got the max and the bottom. All right. You would then know that actually this point here is also an important point. So what you need to do is actually just find the mean of x. This is what we call x mean, right? X mean. So instead of y minimum, now this is x minimum. So in this case here, just rearrange. So y, maybe I just put this as y. Y minus 2 square is equals to x plus 1. So this is x plus 1. So x here will just be y minus 2 square minus 1. So mean of x will just be negative 1. Alright, so just remember that this is the mean of x, because this is always positive or at least 0. Essentially y minus 2 will be when y equals minus 2, so y equals to 2. So in this case here, this is actually minus 1, 2. Alright, so that's the mean of x there. Okay, we need this. This is important. Now, apart from that, we also need this part here. This part shouldn't be too big an issue. What we need is just calculate out when y is 0. So x will just be 3. Alright, so this is 3 here. Okay, so when this is 0, you realize that it tallies as well. So this will be 3. So this point satisfies this equation. You can also just check that. Now, once that is done, we need to revolve this about the x-axis. Okay, so you have to visualize this a bit, because if you are not able to visualize this, it's pretty hard for you to actually just write down the equation now. Okay, so let me just write down how. Let me just model this thing out for you. Okay. So there you go. What we have here is this is region R, and after which we need to rotate about the x-axis. So the thing is, you must be able to tell that as you rotate, there's this this curve that is taken out from below. All right, and this is actually what do you call it? It's actually there's cone, right? Cone involved here. So as you rotate about the y-axis, it looks something like that. Okay, so what we need to do is actually just can we visualize this? So let me just remove the edges here. Okay, it looks something like that. So you need to remove something from inside here. Okay, so if you look at this view here, X-ray style, so you can see that actually what we need is taking from here, add up with this cone behind here, and remove what is inside. Okay, this inside here is important. So this case here, if you can visualize this, let me just draw it out for you. So it looks something like that. You need this thing here. Okay. Minus of this thing here. I mean, add with this cone here. So just draw this out. This cone. Yeah. Okay, like that. After which you just add another line here. And minus off this inside. Alright, so we need to add this up. So let me just required volume. So here, required volume will just be this thing here. Okay. Add with the cone and minus off the one inside here. Okay, needless to say, this is actually an important point here as well. So we actually need to find this point here. We could actually just substitute into the calculator and solve this. So let me just sub this in. This point is important, so I'm going to just sub, maybe I just sub y equals to 6 minus 2x into 1 minus 2 square equals to x plus 1. So this will be 6 minus 2x minus 2 square equals to x plus 1. Okay, so this case it will be 4 minus 2x square minus x plus 1. You can just, we just get 4x square minus 16x plus 16. 4x square minus 17x plus 15 equals to 0. Okay, so essentially I need to find this point here. So key in calculator, what I'll get here is mode polynomial number 2 degree 2, which is 4, negative 17, 15. Okay, you don't need exact value, so it's 3 and 5 over 4. So yeah, so this will be 5 over 4 here. 3 is part of the intersection, so it's 5 over 4. 5 over 4 here. So essentially, we start off by finding this volume here. Now this volume here is important. There are two equations here. So for this equation here, you have y minus 2 square equals to square root x plus 1 or minus x plus 1. Alright, and after, plus minus. So we open square roots, it will be plus minus. Y will just be 2 plus x plus 1 or 2 minus x plus 1. Okay, so it doesn't take long for you to know. Actually, this equation here should follow this equation here, the one on top here. Okay, should follow the positive one. So this will be y equals to 2 plus root x plus 1. Important. After which we have got the other one, which is actually this denominator, this one here, the negative one would be this equation here. So let me just write it down. So anything which revolves around here should be the minus. Okay, just remember that. So when you make this a subject, you have two equations. The one positive will be the one on top and negative will be the one below. Now that's it. So once done, what I'm gonna do is actually just gonna put this as pi dx, right? Y squared dx. So dx from negative 1 here to 5 over 4. So this is negative 1 to 5 over 4. Okay, and this case here will give us y squared. So this is y squared. So 2 plus, okay, maybe I put this as y top square dx plus pi, this is 5 over 4, the y bottom here. Oh, this is the what do you call it, the cone. So you can use the cone formula. I prefer to use the cone formula. So this here, the height is 3 minus 5 over 4. This over here, this height here, 3 minus 5 over 4. Key in calculator. 3 minus 5 over 4, that would be 7 over 4. Do you need the height of this? Okay, this one over here, the y would then be y equals to 6 minus 2 times 5 over 4. 6 minus 10 over 4, that would be 7/2. Okay, so this case here, this is actually 7/2. So if I were to use this cone formula, half 1/3 pi r square, this is my r, right? The height here is r square times the height 7 over 4 here. Okay, then this bottom here, this would just be minus of pi from negative 1. So this inside will be negative 1 to 3, right? So it's actually the inside that we're trying to take out, this inside here. Okay, so if you look at this H style, let me just put this face style as non-X-ray. There you go. We were gonna remove the one inside here. Okay, so this case here would just be pi negative 1 to 3. This is y bottom square dx. Okay, so there you go. Once done, we just gonna put everything on top. This will be equals to pi minus 1 5 over 4. Y top will be 2 plus root x plus 1 square dx. The bottom here, just key in calculator. Not sure what you get, but this is 7 cubed. 24 pi. Then minus of pi 2 minus x plus 1 square dx. Okay, there you go. So we're gonna just key this into calculator. Just remember, can key this into our GC. Alright, I key this wrongly. This is 48. So once you key all this into calculator, we're just gonna add this, plus this, and minus of this, right? The answer will be 78.57. So here will be 78.572. So it's 78.572 cubic units. Okay, so that's how you do this question in Proficient. If you have any questions at all, please let us know and I'll see you in the next question.